Now we're going to talk about a power of a power, or a power raised to a power. Okay, so we have w to the fourth raised to the fifth power. So that means we would have w to the fourth times w to the fourth times w to the fourth 5 times. Well, what we can remember from the last little section is each of these is 4 w's being multiplied together. And one more, good gracious. Okay, so when I look at this, I have a total of 4 being multiplied here, 4 more, so 4, 8, 12, 16, 20. I will end up with w to the 20th power because I have 20 w's being multiplied together. When we look at this, there is a general pattern. A power raised to a power means you're really going to do 4 times 5 to get w to the 20th. When we get to this math problem, we have 2 different bases, so we cannot combine like terms. And we have an exponent outside the parentheses, so we need to distribute. This would be x cubed times 2, because we want x cubed squared, so it's like saying x cubed times x cubed. We know each of these is really 3 x's being multiplied together, so I would get a total of x to the 6th. Then I would do the same thing with my y's, because we know it's y squared times y squared, which is really y times y here, and y times y here, for a total of 4 y's being multiplied together. On the next one, I need to distribute the 3 to everything inside the parentheses. Remember, we talked about calculators lying to you? So I'm really going to think -2 cubed. If you want to use your calculator, include the parenthesis sign. That equals -8. Remember, this has that invisible 1, so 1 times 3 is 3, so I end with w cubed. With my x's, 3 times 7, 21. And then 3 cubed is, y cubed is y to the 9th. You just multiply your exponents. On the next one, again, we have a monomial, all being raised to a power. So I would have a to the 40th. My b would be 7 times 5, b to the 35th. So a to the 40th, b to the 35th. Don't put a times or multiplication or an x there. It would become confusing because we're working with so many variables. When it comes time to take fractions to an exponent, we have 3/4 cubed. I need to distribute the 3 here and there. So 3 cubed is 9. 4 cubed is 64. X squared raised to the 3rd power would get me x to the 6th. That's x 2 times 3. Y to the 5th cubed would be y to the 15th. 5 times 3 is 15. All right, I'd like you to pause the video. This is a challenge problem. You need to use order of operations. Take your time, double check your work before you see my answer. Thank you for pausing. Did you get one of these listed answers? Here are 5 answers students got for me last year, and we kind of discussed and wondered which one was more correct. Do you see your answer listed here? Do you have yet a different answer? Students were able to explain to me how they got their answer, so I'm going to work it out slowly, but the key is order of operations. All right, within this parenthesis, there is absolutely nothing I can do to simplify. Within this set of parentheses, there is nothing I can do to simplify. Exponents come next, so I'm going to apply that exponent to that. Negative 2 squared is 4. X to the 5th squared is x to the 10th. That's the first set of parentheses. I will come to the next set and apply the exponent. Negative 6 cubed, negative 216. I sure hope your calculator did that all right. X squared raised to the 3rd power is x to the 6th. 2 times 3. Remember, this has an invisible 1. I get y cubed. Now I will take my coefficients, multiply them together, and I get negative 864. Here is a base of x. Here is a base of x. I have 10 x's being multiplied here, 6 more being multiplied there, for a total of 16 x's multiplied. I just have a tag along y at the end. That is my final answer.